Before we really get into stacks and start using them and learning how to implement them, we're going to kind of review a few advanced features in Java. Specifically, we're going to be talking about polymorphism as well as generics. Now, the textbook has an entire chapter on polymorphism, but depending on what section of the class you're taking, we may not actually go through the entire thing in detail. Polymorphism is probably a term you've seen a couple places in the textbook, but what I want to do is go through an example to illustrate what exactly it's talking about. So the main thing this is going to build on is material on inheritance. So let's actually go and write a couple classes really quick. So I'm going to start by writing kind of a parent class, something that I can extend from. So I'm going to write a class. I'm going to call this animal, and we're going to say that this has, really all I care about is having a toString. That'll kind of serve our purposes here. So we'll have this toString, and I'm going to return just a message saying, let's say this is an animal, right? Something very simple. So let's go ahead and create a new animal over in our main method here in our simple testing class, right? Really quick here, this, right, is a kind of an inner class, right? Here what I've done is I've created a public static, I should have the word class here. I have a public static class animal here, right? So this is a class by itself. And then over here, right, this whole thing, lines 1 to 12, is actually a public class called a simple class. So I'm kind of nesting one class inside of another class. And I'm just doing that so I don't need to worry about having multiple files or multiple windows open right now. I'm just trying to make it easier for us to see everything at once. Okay, so back down to my main. I've just made this very simple class called animal, and I've had a variable here called A1. So what I'm going to do is I'm going to set that up, so I'm going to put a new animal into it. And over here, I'm just going to display it. So we'll just do a system.out, which is our very simple way, right, to display an object. And since we've implemented toString, right, that was the one method we did implement, this should display this is an animal. So let's compile this. We didn't get any errors. Let's run it. This is an animal. Okay, so everything seems fine, right? This is what we've been doing for a while now, right? We spent several chapters talking about classes, objects, all this kind of is our expected behavior, right? We've just called the method from an object. But our goal was to talk about polymorphism. So let's consider the following. Let me add a child class. And let's say this child class will be called cat. I want to make this class extend animal, right? So cat is going to be a child class of animal. And in here, I'm going to write a new toString. So toString, and I'll have in here, let's return, this is a cat. Again, a simple class. Now I could go over here and put it in my variable too, right? I'll put in a variable called C1, we'll put a new cat into that variable. And let's print it out as well and see what we get. Again, this is kind of simple code, right? So we should get back just kind of this message, right? This is a cat, right after we see this is an animal. Looks like we had a typo. Over here, I should have written extends instead of just the word extend. Let's also jump down really quick and change that last print statement to actually reference the cat variable. So now we're printing A1 and C1. So let's do a compile. Now that works, and we'll go ahead and run it. And we get back the message, this is an animal, followed by this is a cat. So again, everything's kind of working as we expected it. But here's a thought. What if I do the following? What if I make a new animal variable, call A2, and I go A2 equal new cat? Well, let's compile this and see if it works. Notice that it compiled. No errors. So one of the kind of the rules behind Java, one of the typing rules, is that anytime you have a child class like cat, that class, right, an object of that type cat, can be stored into a variable that stores its parent, right? So a cat can be stored inside of an animal variable. Hopefully this makes sense from the perspective that since there's a parent-child relationship going on, cat's going to contain everything the animal contains, right? So anywhere you could use animal, cat's going to have all the functionality to go in place of just a generic animal, right? It added stuff. It didn't remove stuff. So cat, we can put anywhere we have an animal. Well, here's a question. If I were to print out the information A2, what do I get back? Will I get back an animal or a cat? Well, let's try it and see what we get. So over here, it's going to be our new line. Let's call this, right, we need to print out A2 now. And over here, let me clear my output really quick. Let's compile this, and let's see what it is. And in the back of your head, please think to yourself, oh, what should this be? Should this be an animal or a cat? So over here, you notice that we have the messages printed out: animal, cat, cat. Right, so this is the line here of interest, right? This last one, this cat one. So that was a cat object stored into an animal variable. When you do this, you're using a feature called polymorphism. So in Java, when Java is told to print out A2, the first thing it knows, right, is that A2's type is of animal, right? So there should be something that looks like an animal inside there, right? Either an animal object or an object of one of the child classes from animal. Well, in this case, there's actually a cat stored in there, right? Cat was a child class of animal. Well, Java, polymorphically, is going to look at that object and see what it actually is, right? It's not going to assume that it's simply an animal because A2's type is an animal. It's going to look at A2 and see that, oh, it's not actually an animal in there. It's actually a cat, right? It's actually one of those child classes. Well, since it's not actually an animal, despite being an animal variable, an animal type variable, it'll actually go to the cat class instead, and it'll call the method toString from that cat. The way I think of this is that you're going to look for the most up-to-date methods in that object, right, or in that class. Since cat provided a new method, right, a new implementation for toString, Java's going to look and it's going to see that that exists, and it's going to call that instead of the one in animal, right? So it's going to dynamically figure out what's the most up-to-date thing it should use, right? And then it'll call that, so we get the output that corresponds with that child, right, that cat, instead of the parent, right, the animal. So this is called polymorphism, right? It lets us kind of build things around the parent and then put in whatever children we want, and everything that's built on the parent will still function, right? So we have kind of more interchangeability to our code. So this is a nice way to make our code more extensible, but sometimes this isn't enough. Sometimes we want to maybe use types that are completely unrelated, right? They're not just, they don't have this parent-child relationship going on, but they're completely unrelated. So one feature that can address that is called generics. So let's look at that next. So after a brief video cut, we're here back with a blank file. We didn't need any of the testing classes or any of the testing code in main, so I just went ahead and deleted it. So let's start coding up our new example. So what I'm going to do is I'm going to create a new class, and I'm going to call it box. So it's going to be a class that contains something, right? Some piece of data. So let's say I want to store inside of it a string. I'll go string data, right? This will be one of the pieces of information inside of it. And then in addition to that, I'm going to also have an integer. And that integer, I'll just call it ID. In order to set those up, I'm going to need to put in a constructor as well. So let's do constructor box. We won't make this too complicated. So we'll just have a string and an integer, and then we'll assign those to the local variables, right? To the variables that are local to this class. Let's compile this really quick, make sure it still works. All right, looks good. And let's say that we want to have something that can get back the information from data and ID. So let's go public string get data, and then also a public int called getID that returns the ID. So a very simple class, right? It's as if we just have functionality to put a number, right? To put a tag on a string, right? To put it on a piece of data. Still compiles just fine, and we can imagine, using this in our program, right? We would create a new box, and we'd call this B1, for example, equals new box, a word, right? Some piece of text, right? And then maybe it has ID 5, right? And we can compile this. If we run this, it won't do anything right now. Let's go ahead and add in an extra line to print the data that's inside of this particular object. So let's do a println, and we'll do this on b1.getData. So what this line is saying, right, is go to that box object that we just created, get the piece of data outside of it, and print it. So now if we run this, we should get back the string that we put into it. And that's what we get back. So we get back a word. Right now, everything is fine, right? I'm able to do what I want, right? I just wanted to tag this piece of data, right, this string, with some number. But let's suppose that, time passes, and all of a sudden, I want to be able to do the same thing to a different type. For example, to a double. Well, this class is set up to use strings. That means I can't simply go in and put a double, right? If I do something like this, it won't compile, right? It'll give me a type mismatch error, right? Incompatible types. because simply put, a double doesn't go in the same place as a string goes. So if I want to actually have this work, right, if I want to have a compatibility, right, that would let me have a double in here, what I would need to do under normal circumstances is create an entirely new copy of this class. So I could do this, right? I could have box double, right? Rename a couple things in here, change the type. And then this new class, right, which essentially I've just duplicated all my code out. This new class would then be able to store things that look like doubles. So in this case, right, I can put back my double number, and if I compile this, it'll work out. Or maybe not. It looks like over here I kind of went a little bit fast. So inside of our constructor, right, our constructor was initialized in the data that's inside, and I forgot to change one of the types here. So this needs to be double as well. So here we have, right, okay, basically our entire copy of a class that takes in now a double, right, stores that double into the variable that's there, right, the member variable, and then also can get that piece of information back. So this need to be a double as well. The rest of this code, right, like this, right, all the stuff that handles the ID, that all stays the same. Looking back over at main, I'm going to rename this a little bit more. I'm going to call this BD1. So this is going to be kind of our second variable, right, box double. And I'm going to also display it. So print out bd1.getData. So let's go ahead and compile it. Now everything works. Let's try running this. So in this case, right, I now have a word and 1.55. At this point in time, I have two different classes that pretty much do the same thing. They let me put an ID number on a piece of data. The only difference is that one of them is for strings and one of them is for doubles. As you might guess, maintaining this type of code is a pain. Anytime we need to make some change, right, to this class that puts tags on things or puts IDs on things, we have to update it, and we have to update two different classes, right? We can't just update box; we need to update box double as well. The problem stems from the fact that we made a copy-paste of this code, right? We have two different things that are almost the same, but in order to make the types work out right, they have to be different, right? We have to have a string somewhere and a double somewhere else. This is a bad situation. What would be nice instead is a way to make these classes generic, right? To make them store any type of data that I want. Well, that's what Java generics support. So let's try rewriting this code to use what is called generic syntax, or you may also hear it called template syntax if you're in a language like C++. The idea is we're going to make a class use some sort of generic type that's not known ahead of time. And we'll see what that means in a second. Let me go in here and recode our stuff before we talk about it. So over here, I'm going to type in our special syntax, which is going to be an arrow, T, and then the other arrow. And then inside, right, what this T is, right, this T is going to be a placeholder for the type of information that box should store. So over here, I'm going to replace everywhere I have a string with that T. T is just like saying, oh, I don't know yet. I have to wait for the programmer to define what it should actually be. So I've changed it in three places. I changed the thing that's being stored inside, right? I changed the data variable, so now that's of type T, right? Over here in our constructor, I've changed the parameter to also be of type T. And then I've changed our get data as well, right? So that now is returning something of type T. Jumping down, let's update our main. So over here, what I'm going to write is box, and then an arrow, and then a type. Right? So I'm going to say I'm creating a box of strings. And I'll need to put this in two places. Whenever I have kind of my type there, right, box, I need to also put what's being stored inside of it, right, a string. And then over here, I'm going to actually be able to update my second line. And my second line will look like this. Box double. So now if I compile this, now we get no syntax warnings, right? So despite the fact there's two different types being used, and so if we run this really quick, we'll see we get back what we had before, right, when we had separate classes. It says a word over here and 1.55 down here. So now our output looks good, but how is this actually working? So let's take a look at these lines we've just updated over here. So over here, right, we had our initial type, right? This is the class I want to create a variable of. I want to create a box object from the box class, and I need a variable to store it, so I created B1. Well, over here, right, on this left side of B1, this is the type information, right? It tells me what is the type of thing being stored into B1. So we have here, right, the name of the class, so we know it's a box. But then these arrows here, what these arrows do is indicate a generic type, right? A type of information that box should store, right, or should know about. So here we're just saying, oh, build me a box in terms of a string. It'll be up to box to decide what that actually means, right? What we're saying, we say, oh, I want you to have a string, but that'll be defined in the class itself. Here we're just saying box, I want you in terms of a string. The right side has to match it as well, right? So over here, when we have our new statement, we have to have box, and then we have to have string as well, right? To say we want a box of strings. So looking down here at the next line, we have pretty much the same thing. Again, I'm creating a box, but I'm saying, oh, this box is going to be in terms of doubles, right? It's going to be storing with this specific type. It's as if I'm asking for a box specific to doubles. So let's look over here at our class again. So the main kind of work, right, the big change we did was actually up top where we had our public static class box. Over here, right, we had box, arrow, t, arrow. So this t here is actually going to correspond to that string in the double over in the main. So when this code actually runs, it's as if string replaces this t right over here, right? Or this double replaces this t right over here. And in fact, those changes are kind of propagated throughout that class. Anywhere you have a t, it'll be replaced by whatever you bound to it, right? Whatever type you told it to be in terms of. So over here, right, not only would this be a string, but this would be a string, this would be a string, this would be a string. Or maybe they all end up being doubles if we're talking about that second line that we wrote. The point is that t is a generic type. I don't know what it's going to be ahead of time, right? I don't know what it's going to be when I actually write this class right on just in my IDE. But once I actually run my program, then Java will be able to see, they want a class of type string or a class of type double. And then they'll go into that box, right? And they'll actually change this t and they'll update it to be the type that's actually being stored inside this object, right? So instead of just being this generic thing that nobody really knows what t is, it'll actually be replaced by its string or double. Internally, Java is actually going to create entirely different copies of this class for all the types you bind, right? So there's going to be an automatically generated copy of this class called box for storing doubles, and it'll just take those classes and I'll use them wherever you're using those specific types for your generic t. Overall, generics are just a way to make your class contain some sort of type that you don't know of ahead of time. So over here, this class here doesn't have any known type, right? Anything known ahead of time for data, right? You don't know what it's going to be. But with generics, we're allowed to have a placeholder here called t that says, okay, you've built a class around something that you don't really know its type yet. Then you have the ability to actually define what it is. And then this type here would be put in place of all the t's in your objects, right? So then it customizes this class to look like whatever you actually need over in your actual program. If you're still put off a little bit by that little arrow notation, don't worry about it too much. What will happen is that in this next chapter and even the chapter after it, we're going to see generics kind of in context, right? So we're actually going to use them during our implementations of a stack. So we'll spend a lot of time just seeing it kind of in practice, right? Seeing examples of it before we ever look at writing code that actually requires us to use generics on our own.